Welcome to The Explainer. Our digital world is getting crazy smart, right? We've got self-driving cars, automated factories, all this futuristic stuff is right around the corner. But here's the problem. The brain running it all, it's kind of struggling to keep up. So today, we're going to look at a new framework called Cerebrum that promises to give our entire digital infrastructure a much needed upgrade.
So let's dive right in. We're talking about the new Wild West of tech, edge computing. It's where all the real-time action is happening, and it's pushing our current technology to its absolute limits. I mean, the tools we have right now, they just weren't built for this. It's like trying to navigate a jungle with a city map. So what's the real problem here? Why is this such a huge challenge? Okay, let's break it down. At its core, it's a completely new kind of complexity, and our old systems, well, they just can't handle it. So what is edge computing? Well, it's all about speed. It means processing data right where it's created, near the source, instead of sending it all the way to some distant cloud. That's how you get those instant responses you need for things like self-driving cars. But here's the catch. The apps running on the edge are insanely complex. Imagine a massive, intricate chain of dominoes. If just one task is a little slow, it can set off a whole cascade of delays down the line. And honestly, our current systems are just not very good at managing that delicate, high-stakes dance.
And think about the tools we're using, like the super popular Kubernetes. I mean, it's a great platform, but it was built for the calm, predictable, orderly world of a data center. It's like a conductor leading a well-rehearsed orchestra in a pristine concert hall. But the edge? The edge is a chaotic, citywide flash mob where the musicians are constantly moving, the instruments are changing, and the acoustics are, well, everywhere. You can see the problem, right?
Okay, so let's get specific. Let's really pinpoint why these old tools are failing so spectacularly at the edge.
I mean, just look at this. On one side, you've got the world these tools were born in. A nice, tidy, stable data center where everything is the same, homogeneous, predictable. But on the other side, that's the edge. It's dynamic, messy, with all kinds of different hardware scattered all over the place. This is a fundamental mismatch, and it creates three massive, critical blind spots for our current systems.
Okay, first off, they're what we call workflow-agnostic. Basically, they treat every task as an island. It's like a conductor who doesn't have the sheet music and just tells each musician to play whenever they feel like it, with no sense of the bigger piece. It's chaos. Second, they're infrastructure unaware. This is a big one. They can't tell the difference between a beast of a server and a tiny little sensor. They apply the same rules to both, which is just incredibly inefficient. And third, they're single objective. They're hyper-focused on just one goal, like, say, using resources efficiently, while completely ignoring other crucial things like performance or how much it's all costing you or the energy it's burning.
So you can see the current approach is all about reacting. It's constant firefighting. A problem pops up and we scramble to fix it. But what if we could completely flip that script? What if instead of just reacting to problems, a system could actually predict and present them from ever happening in the first place?
Well, that is exactly where this new framework called Cerebrum comes into the picture. It's designed from the ground up to be that smarter, proactive brain we've been looking for.
And the way Cerebrum thinks is just fundamentally different. You see, it's less like a firefighter who's always rushing to put out fires after they've started. Instead, it's more like a fire marshal. It inspects the whole system, analyzes all the risks, and uses data and predictions to stop fires from ever even starting. It's a total game changer.
So, you're probably wondering, how on earth does it do that? Well, let's look inside Cerebrum's mind. Its proactive genius really comes down to two key innovations.
Okay, the first big idea is all about simplifying the chaos. Instead of trying to manage hundreds of individual moving parts, Cerebrum first analyzes what's called data gravity. That's a fancy way of saying it figures out which tasks are constantly talking to each other and sending tons of data back and forth. It then cleverly groups these chatty tasks together into these neat little teams, which they call micro DAGs. Then it can schedule that whole group as a single unit. So it takes this giant, tangled mess and turns it into a set of organized, manageable squads. Super smart.
The second innovation is its brain, a learning agent that doesn't just look at what's happening right now. No, it uses predictive forecasting to actually look into the near future and see what's coming down the pike. And with that knowledge, it makes these incredibly smart scheduling decisions that are always balancing three competing goals. Performance, getting the job done fast, energy, how much power it's consuming, and cost, the actual dollars and cents it takes to run.
Okay, so this all sounds great in theory, right? Proactive, intelligent, balanced. But the big question is, does it actually work in the real world? Well, the results are in. Let's look at the numbers.
And the results are pretty amazing. In a ton of simulations, Cerebrum cut down the average make span, that's just the total time it takes to get a job done from start to finish, by 5.3% compared to the next best proactive system out there. Bottom line, it just gets things done faster. But it's not just about speed, it's also about being smarter with our resources. Cerebrum used 6% less energy. Now, 6% might not sound like a huge number, but when you're talking about this at scale, that is a massive saving. It makes the whole system more efficient and a lot more sustainable. But here, this is where it gets really impressive. The impact on the bottom line. By being smart about when to use its own local, free resources versus when to pay for expensive cloud servers, Cerebrum slashed the actual monetary cost by a staggering 36.8%. That is a huge deal.
But wait, here's the real kicker. You'd think that with all this complex thinking, it would slow down, right? Nope. Even as the system scales up, managing 5, 10, even 20 different locations, Cerebrum's decision-making speed stays lightning fast. We're talking under 15 milliseconds, consistently. Other systems, they just bog down under that kind of pressure. But Cerebrum, it's built to scale.
So let's pull back and look at the big picture. What does all of this mean for the future of our connected world? What we're seeing here is a really fundamental shift in how we manage all of this complex digital infrastructure. By moving away from that old model of just reacting to problems and moving towards a new model of proactively predicting and preventing them, Cerebrum gives us a path to making our future systems smarter, faster, cheaper, and way more reliable. And that really leaves us with one final pretty exciting thought. If our core infrastructure, the very foundation of our digital world, can learn to think ahead, to anticipate the future on its own, well, what challenges that seem impossible today suddenly become possible? What new technological frontiers can we finally start to explore?